Okay, you guys, today we're doing lesson 4.8. Today's lesson deals primarily with the median and the centroid and the altitude of a triangle. And we will touch on all three of those today in today's lesson. All right, let's take a look at our warm-up. Today the warm-up is definitely reviewing what we did not too long ago with slope and finding the parallel and perpendicular equations. Although that is algebra skills, but we're still going to review that. So for number 1, we're finding the slope between 9, -1 and 1, 15, and then finding the equation of the line. So this is your x1, y1, this is your x2, and your y2. Now the formula for finding slope is y2 minus y1 over x2 minus x1. So you could just put that all in the calculator. y2 minus y1 is going to be 15 minus -1. And then x2 minus x1 is 1 minus 9. Since you have a subtraction and a negative, that's going to change to addition and change the sign that comes after it, okay? And when you put that into the calculator, or if you just calculate it yourself, you get -2 as your slope. Now, to find the equation of the line, I don't know if you remember, but it needs to be in the form of y equals mx plus b. That's finding the equation of the line. Well, we know that m is our slope, okay? So we at least know that part of it. So what you can do then is, and I'm just going to use this point, but you can take one of the points, plug that in for your x and your y, and then plug in your slope for the m. And then what you're going to actually solve for is b, because that's what I need. And b is my y-intercept. So for the y, I'm going to put -1 equals, my m is -2. That's going to be multiplied by my x, which is 9, and then plus b, because I'm trying to find b. That's what I need. All right, so -1 equals -2 times 9 is going to be -18 plus b. Then I add 18, because I'm trying to get that b by itself. And that is going to give me 17 equals b. So now I have my slope, I have my y-intercept. So now all I need to do to find the equation of the line is put it into slope-intercept form, which is this form right here. So my equation is actually y equals -2x plus 17. That is my equation. And if I were to put that into the calculator on y equals and then go to table, I would definitely see these 2 points. And if I were to graph it, the line would go through these 2 points on my coordinate plane. So there is kind of a way that you could check your work on that. Okay, number 2. They want us to find the equation of the line that is perpendicular to the line from number 1, that it goes through this point right here. Okay, so this point is going to be my x1 and my y1. I am also going to need my slope. That's my m, okay? And in case you've forgotten, it's been a while since we did this, but we have to use the point slope formula, which is y minus y1 equals m times x minus x1. That's the formula you use. It's called point slope. Now you just plug in using these things here. So I would do y minus y1 is 2 equals, my m is -2 times x. Oh, no, I don't do -2. Ooh, I'm glad I caught that, because I'm looking for perpendicular. If I was looking for parallel, yes, I would do -2. But if I'm looking for perpendicular, I have to do the opposite slope, which means I need the reciprocal of 2, and it's going to be the opposite sign. So it's going to be a positive 1/2. Ooh, I'm glad I caught that. All right, and then x minus x1, which is negative 6. Okay, since I'm subtracting a negative, I'm going to change that to addition and change the sign that comes right after that. Now I'm ready to do distributive. Y minus 2 equals 1/2 times x would be 1/2 x, and then 1/2 times 6 would be positive 3. Now, add 2 to both sides. And my equation that would be perpendicular to my original equation is y equals 1/2 x plus 5. Now, you could always go into your calculator, okay, and go to y equals and enter both of them if you wanted to check it, okay? So y equals negative 2x plus 17. That was my original one. And then go down and enter my new one, which is 1/2 x plus 5, okay? And then go to graph and give it just a second. Let me make sure that you guys can see it, okay? And as you can see, there is the two of them right there, and you can tell that they are perpendicular to one another. So there is a way that you could check it using your graphing calculator. All right, let's get into the lesson for today. Okay, a median is the line segment that joins a vertex and the midpoint of the opposite side of a triangle. So they've kind of already done this one here for us. You join the vertex, which in this case would be L, okay? And they joined it to the median of this other side over here, okay? So what you do is you use a ruler. That's what they did here. They found the midpoint. Now remember, the midpoint splits and makes two congruent parts, okay? And then they connect from that vertex over to that midpoint, and that creates something called your median. Now, you can also do that. You can also do that to the two other vertices. You can do it from point M going across and from point N also going across. Okay, so you might want to just write this down, okay, of what you do. The first thing you do is find midpoints. It doesn't say that anywhere here in the notes, so it's probably a good idea that we write down what we're actually doing. Okay, that way your notes will help you. And then once you find your midpoint, you draw the line from vertex to midpoint. Okay, now that we've written what to do, now get your ruler. Okay, and what you're going to do is you're going to take a look at measuring this side here, which LM, that is exactly 1 inch. So the middle of that is going to be right here at 1/2 inch, okay? So then you go from N, because you take that vertex that's directly across, and then join to that midpoint. All right, and what it's done is, just like these are congruent, these here would also be congruent. Okay, now the last one that we have is going to be for point M, okay, going across. So we need to measure LN. Now this one's a little harder, okay, because when you take a look at that, it doesn't hit exactly. It's not a 1/2 inch. It's not 1 inch. It's neither. It's 3/4 of an inch. Now, some of you might be thinking, oh my goodness, I don't really know how to measure that. Okay, well, this is one way you could do it, probably the easiest way, okay? But every ruler, or at least the majority of them, I should say, is divided into 16ths. And this one even tells you right here, it's 16. In other words, if you started at 0, you would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 would start right at 1, okay? That's where 16 would stop. So in other words, 8/16 is 1/2, and 16/16 would be 1 inch. Okay, so we can measure by 16ths. And this is very helpful for those of you that don't really know how to use a ruler. This is very helpful because you'll measure stuff the rest of your life, whether it's with a ruler or a tape measure, anything that you're building or furniture or finding draperies for a window, just about anything you'll measure. And it's good that you know how to do this, okay? So when we go to count, we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So where that actually measures is 12/16. Well, half of that would be 6/16, and that would let you know that that would be the middle. So when you count out 1, 2, 3, 4, 5, 6, that's going to be right here, okay? So 6/16 would be the middle or the midpoint of the other side. And then all you have to do is join that midpoint to the other vertex, and there's your other median. Now this also creates congruent sides here and here, because that's what a midpoint does. It divides this into 2 equal parts, okay? So now basically you have the medians of your triangle, okay? Now, let's get on to the next vocabulary term, which is called a centroid. The centroid is the point of intersection for the medians of a triangle, okay? In other words, right here. This would be my centroid for that triangle, okay? Here is your median theorem, okay? And what that says is the medians of a triangle intersect at a point that is 2/3 of the distance from the vertices to the midpoint of the opposite side. The centroid is the balancing point of a triangle. So just on a different note, if you had like a little board and it was cut out into this triangular shape, if you could find the centroid of that, you could put it on top of this pencil and balance it, and it would balance on top of that as long as you were at the centroid. It's the central location in the very center, and it will balance out, okay? All right. Now, this looks a little eek, okay? But you will use this to help you find measures, okay? So let me just explain what all these letters mean, okay? If G is the centroid, then AG is equal to 2/3 of AD. Okay, so let me explain what it is. Here's AG, okay? And here's AD. AD is all the way across from vertex all the way across to the other side, to the midpoint over there on the other side, okay? So this is what it's telling you. If I just wanted to know AG, it is 2/3 of whatever the whole length is. So you'd multiply 2/3 times this whole length, and that would tell you this part, okay? If you wanted to know right here, GD, that's only 1/3 of the whole entire line, okay? So if you wanted to know this longer piece from the vertex to the centroid, that's going to be 2/3 times the whole line. And if you wanted to know from the median to the centroid, that's going to be 1/3 of the whole line. So that's what these letters are telling you here. You will be referring back to this, and that's okay. All right, now, if you wanted to find DG, but they didn't give you the whole entire thing, then this part is half of this part, okay? Because if you have 1/3 here and 2/3 here, that makes sense because 1/3 plus 1/3 equals 2/3, okay? So it just kind of depends, and as we go through the different questions, we will be referring back to this because that's the easiest way to do it, okay? So let me just repeat again, and I'm going to use a different line this time. Okay, so for example, if I was trying to find this one, okay, I have C all the way to F would be the whole line. If I wanted just CG, this part, I would do 2/3 times the whole line. If I wanted this small part, I would do 1/3 times the whole line. If I don't have the whole line, then this piece is half of this piece, okay? So it works, that's how it works all the way around on a triangle, okay? And let's actually like practice a problem, because maybe that'll help a little bit, but you will be referring back to your notes for sure on this one, at least until you really get the hang of it. All right, so let's take a look at example number 2. It tells us that, we got it on here, here we go. I, K, and M are midpoints of the sides of triangle HJL. So HJL, that's your triangle, and I, K, and M are the midpoints. So that lets you know I splits this one into 2 equal parts, okay? And remember, you guys, I've always told you with geometry, they just kind of expect you to remember this stuff. So this would be one of those things where you look at a triangle. If they tell you that's the midpoint, then you need to remember, oh, okay, a midpoint splits something into 2 congruent parts, okay? That just helps you in the future. All right, so let's take a look at this one now. I'm going to lightly sketch when they give me a measurement, okay, just to kind of help us. All right, so it says if JM equals 18. So JM, that's that whole line is 18, okay? They want me to find JN, this part, and they want me to find NM. Now, just as a review, up at the top, and this is what you can do. When they tell you to find this line, look directly at the same line that we have in our notes, okay, and compare these letters. It would be this one, CGF, okay, so it's going to be these right here. That will be directly related to what you're trying to find here. So just kind of look at the letters and match up what you're needing, okay? But as a review, if my whole line is 18, JN is going to be 2/3 times 18, and NM is going to be 1/3 times 18. And then I'm able to find the 2 of them, okay? So to find JN, I just need to multiply 2/3 times 18. And you can do that now on your calculator. 2/3 times 18 is going to be 12. And then to find NM, and I'm totally okay with you putting arrows like that, that's fine, and then box your answer. Okay, now to find the smaller piece from the median to the centroid, that's going to be 1/3 times the whole line, which is 18. And that answer is going to be 6. Now, if you wanted to check, which you could, add the 2 together. What's 12 plus 6? 18. The whole line is 18, so yes, that makes sense. All right, now let me erase, and let's take a look at the next question. Okay, now for the next one, it tells me that HN equals 14. HN, so that's this one. This one, this piece, is 14. They want me to find NK, and then they want me to find HK, which would be the whole line. Now, if you needed to refer back to your notes, you can say HN, okay, that's going to be the same as AG. All right, so then find the letters that match this line of AG and DG, and then the whole line, okay? All right, so what you need to do is, we already know that this piece is half of this piece. So that's going to let me know that NK is half of HN. So NK is half times 14, which is 7. Okay, so I know this piece is 7. So now HK would be the whole line. And what's 14 plus 7? And I'm writing this down for people that aren't here for their notes, okay? So 14 plus 7, that's going to be 21. So the whole line would be 21. Okay? All right, let's move on. Okay, now we're going to have an algebra connection. As usual, we usually do that. And it tells me here H is the centroid of triangle ABC. And it tells me that DC, so DC is this whole line, is 6y minus 15. So that whole line right there from here all the way down to here is 6y minus 15, and they want me to solve for x and y. So now you just need to take a look at this. Okay, if I'm solving for, you could even do, okay, so I'm solving for x, okay? If I solve for x, these are the two equations that have to do with that. So you need to take a look at that and say, okay, well, how do these two pieces relate to each other, first of all? Okay, do I even need to know what DC is? DC has a Y in it. Okay, well, I'm not looking at Y right now. I'm looking at the X. Okay, so how do these two sections relate to each other? Okay, that's basically what they're asking. All right, well, this is 2/3 of the line. This is 1/3 of the line. And like we said a minute ago, this is half of this. Okay, or 2 of these equals 1 of these. So 2 of these equals 1 of these. All right, so that's the way we can set it up. 2x minus 1 plus 2x minus 1 equals 1 of these, which is 3x plus 6. Combine your like terms to get 4x minus 2 equals 3x plus 6. Subtract 3x from both sides, and you get x minus 2 equals 6. Add 2 to both sides, and you get x equals 8. All right, now let's take a look at solving for y. I know the whole line, and I know this one, the 2y plus 8, 2y plus 8, okay? So I know from my notes, if I'm looking from vertex to centroid, okay, which you could look up here if you're not sure, from vertex to centroid is 2/3, AG is 2/3 of the whole line, okay? So it's like 2/3 times the whole line will give me this piece. And that's how you set that up. You would do 2y plus 8 equals 2/3 times the whole line, which is 6y minus 15. Yeah, I know it's going to take you a little bit of time because you need to use your calculator, okay? But 2y plus 8 equals 2/3 times 6y is 2/3 times 6y is going to be 4y, and then minus 2/3 times negative 15 is going to be 10, so that'd be minus 10. All right, then subtract 2y from both sides, and you get 8 equals 2y minus 10. Add 10 to both sides, and you get 18 equals 2y. I'm out of room. Divide both sides by 2, and y equals 9. Woo, I know, that's a little bit of a workout there. Just take your time, okay? And I'm going to allow you plenty of time to work on this, okay? Now, the last thing we're going to talk about is the altitude. And this is something that we don't necessarily like work problems out in our notes, but this is just something you need to understand about the altitude, is that that's the line segment from a vertex, and it is perpendicular to the opposite side. Okay, so notice it has the 90-degree angle marking there. Okay, that just lets you know that that is perpendicular. It did create a 90-degree angle when it hit that point. Okay, and so something else that you need to know, because soon we'll be getting into finding the area of a triangle, and also volume and various other things like that, different measurements, okay? And you need to know that the height is also known as, AKA, okay, that's going to be the height of your triangle. So I know you've heard of that, because I know you guys have tried to find like the area of a triangle is base times the height times half, okay? Or half base times height. And And so that's where the height comes in. And just as a way to explain that to you, like for example, on this triangle, well, this isn't really an accurate representation of the height of that triangle because that line is slanted. However, if you make it vertical, if you make the vertical line here and you make it perpendicular so that it is exactly straight and creates a 90-degree angle, this would be the accurate height of that triangle, not the slanted line. Okay, so it comes in different ways. Sometimes it might be inside. That would give you the exact measurement of the height. This one kind of has to go on the outside, okay, because this needs to create the height for this one. And then, of course, this one's right here in the middle. We've seen these before, and we've seen the right triangle before. But this creates the actual height of a triangle. And it does say here, if the triangle is obtuse, which this would be, then your altitude is outside of the triangle. The rest of them will either be the actual leg or it will be inside of the triangle. All right.